Da-dum-bum-bum. Oh my goodness, there you are. Really, really good to see you. Thank you so much for stopping by and sharing a little time. Today we're going to talk about on-disk project architecture. I see a lot of people sort of moving between different patterns, of which many have been quite valid and at some point were brand new and wonderful and solved some relevant problem over the last 20, 30 years of the Microsoft .NET ecosystem. And really this can be applied to any project. Anytime you are writing code, if you get more than a couple of hundred lines, you need to think about how I might break this into classes. Maybe I've gone too procedural and it's just very scripty, and if I ever plan to grow it or use it or change it in the future, leaving it in this way would be a bad idea. Fine, you broke into a couple of files, you've got a little bit of modeling going on, great. Your project's 5 files big and has very low future change situation, like it's fine. That perfectly makes sense. You start feeling like putting more than one class in a file, or all of a sudden you've started to repeat yourself in different parts of your files. Maybe you still only got 5, 6, 8, 10 of these. Now you're going to start wanting to reach for folders. You're going to want to start to maybe reach for namespaces and start to kind of organize things. Maybe you're going to want to reach for a few higher level concepts where you could share certain pieces so you're not repeating yourself, right? This is a natural evolution of honoring the size and scale and complexity of what's in front of you, and honoring in 3 months or 6 months what you would like to come back to and what's going to read well and tell a good story. The robots are already good at being robots. The compiler's good at being a compiler. The whole situation of the mechanics is optimized very, very much so for itself. What we need to do is optimize our code and our on-disk project architectures absolutely for readability and for the human and for what needs this thing will have throughout its growth life cycle. And that should, you don't show up day one and implement every design pattern on the planet, nor should you show up day 6 and ignore that growing feeling that your project is getting a little bit messy. So let me show you the little and the big, right? And we'll just have a conversation, right? So we're going to explore this from a lot of different angles. So let's look for a few overarching facts before we get in here, and we'll get some initial look at some of these patterns that should be showing themselves. All right, so just for a reference point, this project that we're exploring has 81 projects in it. So there are 81 different projects. As you can imagine, most of these are going to cook down to DLL files or RCLs, and some of these are executables that like run tests. Some of these are API endpoints that are hosted. Some of these are the Blazor WASM client and server. Everything is in here. Okay, so this is I wouldn't call this big, right? This is a very young project that is not doing very much yet. But it is a result of our overall development over the last several years of a kit that we use to build projects. And so there's a little bit day one, a little maturity already built in. First, naming. Like, you're going to find such hardcore, consistent naming across these that you can pull any one of these up and know exactly what is in there and what is going on and where you would need to go and what you would need to touch to affect change in the system. But I just want to pull this number out. So it appears, if this is all to be trusted, there are 81 projects inside of here, organized, and we're going to take a look at that. So if we collapse the world down in our root, all the interesting stuff for our on-disk project architecture, specifically .NET code, lives here. But you're also going to find patterns like this SRC folder and when to use it and why we embed it periodically. In this case, it's quite evident, right? Source code is one of many topics at this level that we need to accomplish. We got stuff to deal with around our Docker builds, our compose stuff. We got stuff to deal with around our terminal loaders. We got miscellaneous files, right? And so if our source code was also here, that would look awful, right? So there's organization tip number 1. when you're about to navigate into a container clean piece of code, drop a source folder so that later when you come back and you want to add a manual or a conversation or some things about the work, you have a place to do that. All right, at the root of our source, you're going to see I have forced the sort of our stack. There's a bit of an onion orthogonal clean architecture with a tiny hint of sort of feature slicing at the right points. And as you fall your way down, our dependencies basically follow the same. So between all of the projects, kernel, if you are a disconnected client, or kernel client, if you are a connected client, kernel shared, right? So we don't ship an amount of our kernel to disconnected clients. Shared inherits clients so that connected clients can have all of it. And we have a little bit of UI testing going on that there's some experiments. Anyway, next we're going to see common. And so this is really a common UI, and he had a hard time deciding where to live, but there is pretty much a inheritance flow. So most of the time his posture is up here. So he went ahead and lives up here. So within second tab common, we deal with master page layouts and master state stuff that is extended to other parts of the system, and some managed render fragments, common. So let's look at something like the common kernel that pretty much every project is going to use kernel. Most of the projects, the kinds of things that are in here are highly reusable. Our base entities and base domains, the idea of app settings and endpoints and feature flags, um, some shared value objects, stuff, goofy little utilities. Great. Shared kernel. We're here to talk about folder structure, so why not get started here? And we see just some common patterns you've probably seen before. These often are going to be reflected in the namespace, and so here we see really the second tab .kernel shared DLL. This library includes you could almost consider it a folder, like a virtual folder. You're kind of saying, listen, if you are in this library and you look for a virtual folder of configuration, you're going to find all sorts of things like this. In this case, these three classes. The other half of these are maybe your global usings or your import statements at the top of your files, where you're using the library, and then some amount of the rest of this is folders and subfolders mentally within that library where things are organized. And if you import second tab kernel share configuration, you're going to get app settings, you're going to get endpoints, you're going to get feature flags. It's also why they exist. Endpoints is kind of generic. And so if you're later trying to talk about endpoints, your system has to say, well, which one did you mean? Did you mean this one or that one or the one over there? And all of a sudden, common phrases can start to kind of run into each other and become a hardship. We don't want common phrases leaking out and causing hardships later. So we use these sort of namespace identifiers. Maybe you've only ever imported this namespace, and so all of a sudden it immediately knows this is the endpoints you're talking about. Or maybe you need a way to reference. Very specifically, I want that particular endpoints class or interface. Right, here are interfaces. You're going to find a folder called interfaces. You're going to find generally a namespace. Now, I don't have to. There are moments within a very large build where the right thing to do really becomes to just say, you know what, if you have this library and you have imported this library, you're going to have everything that's inside of this library. Right? A lot of your favorite tools and libraries that you work with, you don't have to fill your project for usings file with imports for a dozen namespaces. You generally import the root, maybe the root and a folder. Air quotes. It's not a perfect analogy, but I want to keep it. All right, super cool. So that's what's up, right? We're organizing these things. Part of the reason why, another good argument I would say is, if I'm looking at a bunch of classes in a organized space, I'm going to assume the classes themselves should read very similarly. The pattern in here, in this case, these really are models, I would say, but the pattern in here, as I compare them to one another and as I apply thoughts and philosophy to the kinds of problems these kinds of classes are solving, I'm probably going to want to look to its siblings to see if that is applicable to them. And I know I'm not going to run into other types. I'm not going to get all tripped up and have to change my kind of brain space over and over again. I get to get real specific. And we'll see much grander examples of this, as you move into more complicated situations where we really are looking at a large set. I don't know, let's go way out here to an application shared set of request objects, and all of a sudden every single file within this space should look and smell and feel and behave and honor the very same, very specific set of patterns. And I love that about it. I love how slicing by the technology behavior in certain moments creates that fantastic situation where it is, I put on my brain hat about this kind of set of systems, and then I'm able to apply that thinking to that system and its neighboring systems. And then when I switch from services to testing data, I'm not, there I see. Oh, I see. This is clearly my static test, right? I love it. So that's how I'm using them, why I'm using them. 85% of the time in my builds, you're going to find, maybe more, 95% of the time, you're going to find namespaces tend to follow physical folder structures. But again, they don't have to, and you will find moments. Here's a good example. In my cores, I drill into these entities, and I like to organize them on disk in this particular way. But if you were to drill into any given entity, it's actually going to stop tracking namespace at the word entities. So all of the entities, which should be small, right? These are very small. They're all kind of worrying about a small set of problems at a time. Um, but within this system, if you imported account module entities, then you're going to get all my entities, and then you would have naming conflicts if that became a problem. It's just different areas in the system. We don't do that, so that isn't our problem. All right, let's leave account kernel. Let's leave system-wide kernel. Anytime you see the word second tab, that's a system-wide concept, and the rest of these are generally scoped and namespaced to their own intent. And so account module is going to be scoped to account module. Super cool. All right. The plus plus is telling me this or something inside of it is hosted or deployable. So the plus is telling me that. The plus plus is telling me this is probably hosted, but more importantly, it's like a third-party system or it's something really sectioned off in my builds. I can replace the entirety of identity or update it or deal with it, and it is outside of the purview of certain things. I can take it out of filters on global find and replaces. I can, I've got it tucked away very nicely, and there is that project. Signal R, again, kind of standalone. It's not third party, but this is a standalone server, kind of special to the rest of the build, and so we have that up here and managed with these plus pluses. We get into the pluses. If we follow the plus, we'll eventually find something deployable, right? And so this API here in its own right is deployable. Let's go back up though. We have our modules. And so we have required modules and we have lazy modules. So these required modules are going to get injected when the application first starts up, and the lazy modules are going to get injected lazily along the way, provided some checks have been met. You've paid your bill, you deserve the module, you're logged in as an admin, and they're a manager of the site you're looking at, and blah, 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 these kinds of things. For UIs, we have client. It's the Blazor WASM client. We have a console app that's not very developed, just mostly jokes, but keeping ourselves honest. If it's pretty easy to wire a console up to take advantage of this entire stack, then we've done a good job. And it's fun to see modules, lazy, just this whole thing is very cool. But that's mostly silly. Maui, we do have a Maui build that Not in this one. We could bring in, and we have a few Maui builds. They're really treated a lot like this pre-render server where the effort here is minimal. There's like nothing going on. It is just a pre-renderer that bootstraps the clients so that the client can go ahead and preload the required modules and then manage the lazy loading of those other modules. So even our client is super thin. And this is really, I think, the most ideal state where the client is just an expression of UI. The console is in many regards no different than the Maui, than the client, that the server. That it's just an expression of UI. If we wanted to go from Blazor to some other technology, I'll use Angular for a minute. Now I would have to change my data service layer because it's TypeScript instead of C#. I'd have to do some conversions, but it would not be very, very hard to say replace the UI. Right. If you want all my free stuff, if you just want to build an Angular thing and use UI, APIs, and the APIs use the rest of the stack, of course that's going to work. But if you want all the magic and the automation, and I'll show you here in a minute a little code gen that I do, I would just create a quick little TypeScript variation, and away we go. And now you could have both sides pretty cheaply. The point of that was the UI should just be an expression of that final moment where all of the things have come together, but it's not very smart. There's not business logic in it that is overly meaningful. It's more like the HTML it's built on. It's just a template of expressing the thing. It's not the thing. If you build like this, if you built like this 20 years ago, you would not be changing the core of your stack much at all, if at all. Like, so much of this could have been written 20 years ago and not needed to change much. It's really just these UIs and these expressions of that business intelligence that is changing quickly. All right, so this is very high level, big buckets, but it makes me happy. This on disk project architecture means I can collapse the whole world, and in a moment, I could go exactly where it is I need to go to affect the kind of change I want to affect in the system. That is the point of it all, and it's wonderful. And we see my silly abuse of the English characters continues. So the actual work, we've kind of seen plumbing, a lot of plumbing. The actual work lives inside of the modules. So if I look at the live polling module versus the account module versus the live room module, first, yeah, absolutely the same set of patterns. If in fact, if I mess this up, I have a system that'll tell me you're out of sync. I want this to be very predictable. This is not what's interesting. This is one of the harder things to do, but it should not be. So let's make it not hard, right? Within these, you're going to see the same thing. This is an entire application. We have our core domain, infrastructure. We'll see some things I've done here with data and pulling out the migrations and data seed scripts. We have our application and application shared layer. We have our API controllers and endpoints. And finally, we cook down to Razor class libraries that can then be injected into the final product. This is a standalone application. It has its own database, or it could share a database, or like you have all the options. But by default, each of my modules have their own database. If we unpack further, again, I'm going to keep walking top to bottom. There's an incredibly beautiful, important thing happening here. I can go up to my core. I can look at domain entities, aggregate roots, value objects. I can make an adjustment, right? A lot of you will be like, okay, I need to add a field or whatever. Fine, add a field. Now, what do you want to do with that? We're going to add some tests, right? So we've got everything here, and we've got some static test data that can be provided to other parts of the system. Like this static test data is available to everything in the system except for the disconnected clients, and can be used to run data seed scripts and initialize data in data structures, be it a live database or an in-memory or etc. It can be used. And then part of my system actually takes this static test data cleans it up, converts it into view models, and we'll see some of that at the other end of the stack. And then that test data is recreated for the disconnected client in a meaningful way, which means that at any moment in the entire system, we can write automated tests. We could create UIs and screens using, intelligent mock data that's already built in for us. Solving these problems. Solve them. All right, so we're going back out. We got some unit tests. We got test data. And it's all organized here where it should be. And we can run all of this. We should be able to run your system in memory. It's not going to persist. We're not talking about persistence. We're just talking about spinning it up, giving it good values, seeing it happy, giving it bad values, seeing it protect itself. Love it. Now, also within our core entities, we have our specifications, and we would have our domain events and domain event handlers. We could have named exception classes. All that stuff would be just organized here. Pretty typical. We leave core and we move to infrastructure, and we see command queries. So our CQRS implementation is chilling in our infrastructure. And if you look at any of these specifications, right, these are just executing links. So whether it's a list in memory or later ND frameworks using it to execute against database, these will run. So we can execute this against our entire system while it's in memory. We can load the system up with data. We can execute some of these queries. We can see the behavior of the system. We can write those automated tests. Very tasty. Cool. So we move into infrastructure. Right? Infrastructure, we see our CQRS, our command query responsibility separation start to play out. And so we have commands and queries that wrap our generic repository to expose an ability for Mediator to help us later implement our CQRS patterns. And we see our DB context, and we see named generic repositories so that later AutoFac and other dependency resolutions can take these generic repositories, and we can have lots of them, and they can differentiate between them. That's his only job, right? He's good at his job. We got some infrastructure tests, and continue to make sure there's a good pattern in place so that when we hit deploy at the end of our first sprint, that's an example of a thing that we're going to now make better, right? We've pulled a thread all the way through the entire stack. For me, data, I've separated out the idea of data migrations and the idea of executing seed scripts, which really just look for that static test data and then generate all of that static test data as initial database seeding scripts. So again, if it's an in-memory database or an on-disk, or maybe you've got SQL in production and SQLite over here and in-memory over here, maybe you're standing up full SQL in different containers to do your testing. A lot of different kind of situations you might want or run into, and this supports taking care of that. You're also going to find, we're starting to get into something a little bit more rich and fun, and so we do a lot of greenfield development. So stop and build tiny little scripts. Stop and build things that help you build faster. And so you'll find within each of our data projects, we have these migration shortcuts and ways to kind of reset all of the migrations and things just handy, right? So as an engineer, you have those available and you're saving a ton of time because these are things you run all the time. And so cutting a little time out of that is significant. All right, we're moving into the juicy stuff. I would still say, core was really the juice, and the rest of this is like plumbing, right? So the really interesting stuff lives in core, where we have our business intelligence and we have our ability to kind of protect and manage information that we could stop it from being put into memory if it's not healthy. We can safely protect the state of what we're up to. And I should leave a count. There are far more interesting modules. I picked it. Account module application, we'll start there, creates, exposes, wraps this idea of a service that can be used to directly talk to Mediator, which is going to invoke those CQRS pathways through our system to access data. Right, so this is us basically saying all that other work is internal and ours. Now we're beginning to describe how other systems that want to interact with or talk to us are going to do that. So we're describing at this moment, if you have direct access to our libraries and you have direct access to your server and you have direct access to your database server, then you can take advantage of this data service layer that will wrap all of those interesting calls. So you just pass a request in, you get back a view model, and it works out all of the difference in the middle. Super cool. So our module application, this is for trusted, our API has access to this. Our Blazor server has access to this. Other things we might write internally have access to this. But if you're a disconnected client, this was a piece I would write differently. In Angular, I would just convert all this to TypeScript. But otherwise, between those two languages, you could have yourselves a service layer that you simply use. So this would be referenced by that disconnected client. That disconnected client instead is going to be interacting with over HTTP instead of that direct access. They issue the exact same request, they get back the same view model. And in this case, the API itself, if we pop over to the controller that this shared module is pointing at, we actually know where that is if we want to look at the request. So if we're going to look for like a known account add request, I don't know, the request object itself describes its controller endpoint. And so we could then go to our API. We're almost through the whole stack. We could go to our API. We could see we have known account, singular, and known account add request. Takes in that command, and I'm sad. This should not use mediator. Let me look. Let me look at one. Huh. Egg on my face. Please hold. Let's go to another module and see what's going on out there. All right, the question here is about API controllers. Bum, 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 bum. All right, this one's doing the right thing. So we'll proceed from here and assume the other one was too. It's simply asking data service, which was injected from, you guessed it, application. So that same service we were looking at that our API does have access to, it's just going to use, right? So the controller uses that same data service to go ahead and satisfy the request. It's super cool. I love it. Now I got to go upgrade account. All right, all right. What's going on now? So we've described we built something cool in core. Let's follow this one for a minute. So we have the idea of a live question in core. When we made this live question in core, we just as well might have gone all the way down here to application shared view models and made a live question view model, right? So in this case, right, you're going to have other view models, DTOs, but in this case, we might want to hide parts of the result set or map the whole thing. We definitely want to strip out all the business logic, right? So that we're not shipping our internal business code to those disconnected clients. We want a very kind of thin representation, an anemic model, if you will, for the view and the DTO. So we made that entity. We came out here, made this view model. This one is, let's decide something to do with it, right? We'll go back and forth here. That'll be described here. Let's say this one's pretty wicked. Let's do a simple one here. Live question get by room ID. Specification pattern says give me a room ID and I will filter whatever you've asked me to filter on that room ID, right? So fine. So it is way up in the stack. It doesn't know anything about those view models or anything at this point. This needs a request. So live question get by room ID request would be kind of this fourth thing we would do. So let's go back down here to shared. Look at these requests. So again, shared ships to the disconnected client. That's why these are all living in here. Live question get live question singular versus live question, right? It's very organized. Live question, get by room ID. Of course, I had to pick another one that is not used or implemented. My apologies. I should have practiced. Let's go take that wicked one. I know that one's implemented. Live question, get by ID with votes. Okay. So we're going to come down here to live question, get by ID with votes request. This is what the disconnected client would create and then hand that to the service. It seems to support a slug and a live question. Good. This request needs a query. So if we go now to infrastructure, we're looking for live question, right? And it's a query, get by ID with votes. This is exactly what the request is, give or take a couple of little things. Now, we use AutoMapper to map between them. We'll see here in a minute. We describe AutoMappers for each of these, and we get to ignore that. And so we could hand in the query, but then the query would know something about that route, how to build the route, and I didn't like that. And so again, I think you have to create the right patterns for yourself, but the cost of getting from a request to a query through AutoMap is very simple. So I took it. Otherwise, these are very similar. The query then being introduced to iMediator on both sides, then is handled. The specification is created, the specification executed against the generic repository, and then the results are returned back to the API who called it. And so if we look at that final piece, then we would need to go out to the API and create a controller for a live question, and that live question would need to have this get ID by votes, takes a request, and ultimately is going to return the live question view model. Just close your eyes and throw a dart exactly where you need to be, depending on what kind of change you want to affect in the system. Now, who would I be if I didn't pull us through the final pieces? So all of that matters because maybe I'm over here. Let's see, I'm doing a get ID with live votes. That's going to put me in an administrative report here. So here I'm in the UI layer for this micro application, I'm going to call it, that can be lazy loaded. I've got this admin reports. We've already injected an account data service and an account data service not authorized. We'll go look at where those are wired up here in a minute. So now my module Razor page here can jump right in and take advantage of asking that data service politely to go get all rooms by ID async and pass in a new request that needed that live room ID. It's just lovely. 2 or 3 kind of moments that we needed to do some business intelligence, we need to do a good job, and the rest is plumbing. And it's organized in a way that, so many advantages. I'll try and come up with a list, and I feel like I'm running out of time here. All right, so we have now got all the way to the point of a UI that can express all of these things, and then I think the last thing that might be interesting is if we'll come out here to the Blazor client, and we'll continue to follow that live question, which is part of this LP mods lazy module. And we can see the HTTP client and the not authorized HTTP client are registered here and injected into the dependency injector so that later that lazy module can ask for these named HTTP clients and use them, right? So they're introduced out here on the client, and that library up there just uses it, just does what it needs to. We also inject the data service. If we come back up here and look, we're going to see if the disconnected client wants the data service, it's going to get the HTTP data service provider instead of that direct data service provider. And we're going to introduce the service that uses that tag back so that we can in fact, it's sort of lazily, right? So the actual modules themselves are lazily loaded, the RCLs are lazily loaded, but there are some preamble here where the client does need to be able to register certain things in dependency injection, for instance. So it does know a little bit about those lazy modules, and more to be learned and grown and from there. All right, that was super cool. What else was going on? Not a lot. The way I'm kind of breaking the project import files apart so that we can get to those moments and introduce those lazy modules. And you just come into the project file itself, you'll find, boom, you can simply reference and import each of those. And so if we import build module targets, it's going to import all the projects that matter. Similarly, if we come in and we come in here to register module services, it's just a static extension method I've added to here, which will take that WebAssembly host builder, and now again it's going to iterate just like the other pattern through each of those so that they can register their own services for dependency injection later. I think that's the whole life cycle. I think that's it. I think if we collapse and look at the on-disk project architecture and we've paid such fine attention to it, we can now do wild things. We have tools that can take sections of these things, pull them out, do some really deep renaming of namespaces and classes and code and folder names and file names and create other expressions of things. We can move entire chunks of these to different locations. If I take this lazy module, or more likely, I take one of these required modules and move it into a new project, it's just gonna like work. I'm gonna add like 3 little statements to the main whatever UI cares, and all of a sudden I can now take full use of that entire micro application. Hope there was something in there for you. If you got questions, raise them. Let's do this together. Let's bring more sharing and on-the-job training uh, to our industry so that we can all have a much better time building amazing software. Hope that was useful. So much we could possibly look at and talk about. You're going to have to direct the conversation from here. Happy holidays. Amazing rest of the day to you. Cheers. Da-dum-bum.